In last class, we discussed about example for Bayesian classification technique. So already Navy based classifier technique. So already we concluded about how we calculate test cases. So this is the last class we discussed. So in order to calculate posterior probability, this is a likelihood probability we called x by no. So this is the class label and this is attribute. If you are calculating posterior means attribute for a given attribute, you are calculating find out in class label. So that already we have a data. Next, based on this, we are calculating all the parameters. Okay. Coming to the next session, we are starting with a topic called as characteristics of Navy based classifier. These two topics we will be discussed in this session. What is the characteristics of Navy based classifier and what is Bayes error rate? Okay. So the characteristics of Navy based classifier has some following characteristics. See, they are robust. They are robust to isolated noise points, such as points are averaged out in estimating conditional probabilities from data. So it is very reliable when we are calculating isolated noise points. Isolated noise points means, see, all are various parameters. Okay, so one value and one value should not be correlated to each other. Okay, so these two are independent values. So for example, you are taking homeowner, if you are taking particular salary or annual income, and you are calculating marital status, and these three attributes are independent to each other. So this Navy based classifier is used or very reliable when it is a isolated noisy points. So that such points are we calculated with the help of averaged out when estimating. We calculated by means of estimating conditional probabilities. Okay, based on estimated conditional probabilities, we are getting some average of data. Based on average data, we are filing particular values into isolated noisy points. Okay, and these are very reliable to irrelevant attributes. Okay, so already in previous in this session we discussed. Now we have a drawback. These two are very important when we use a particular what we call as Navy classifier algorithm means these attributes which are independent to each other based upon conditional probability. Okay, see, and the robust to irrelevant attributes. But in the case of correlated attributes, if you are taking a particular relation, in that relation the two or three attributes are correlated attributes means it can degrade the performance with Navy based classifiers because these are conditional independence. Assumption no longer holds for such attributes. Okay, if these attributes are conditional dependence means we are getting particular what we call as, see, this is a case if you take a particular value, if you are taking a 0, if you are getting a particular 0 value, so that you can easily identify that this is a conditionally dependent to each other. If you are getting 0 means it is a conditionally dependent to each other. If 2 or 3 attributes are conditional dependent on each other means it will not be performed. Naive based classifier will not be performed efficiently. Okay, so that we have a particular feature called M estimation of conditional probability. So this is the case when we have a scenario, we get a 0 value. If you are calculating Navy basic classifier, so that if you are calculating that particular concept with a test case relation with a training set, by using the training set and calculating test cases, so that if you are getting a particular 0 means, so all the values become 0. So if it is 0 means we are not considering the values. So whatever the 0.01 case is a best one case when compared to 0.01 case is a best case, so that we predict that variable as class label. Okay, right. See, if M estimate of conditional probability is used to calculate, see, if the class conditional probability for one of the attribute is 0, then overall posterior probability for the class is vanish. Okay, see, already we discussed in previous class. In more extreme case, if the training examples do not cover many of the attribute values, we may not be able to classify the sum of the test records. If you have the 4 or 5 values means, so that we may not be able to classify particular sum of the test records. In this situation, Navy based classifier will not be able to classify the record. So if a property have a correlation property or correlation attributes, then Navy based classifier should not be performed very efficiently, because if the correlated attributes means, so the value will be 0. When the value will be 0 means we cannot be calculate particular posterior probability. Okay, so this problem can be addressed by using the M estimated approach for estimating the conditional probabilities. We use some M estimate approach for estimating the conditional probability. For example, you take P of xi by yi. So that for a given yj value, you are calculating, you're find outing what we call as xi. Xi means attribute. So that nc plus mp by n plus m. What do you mean by nc? Means you are calculating mean value, you are calculating probability, you are calculating average value. See that where, see where n is the total number of instances from the class yj. N, we are calculating n. N is the total number of instances in yj. If I have 10 values means the n value is 10. If I have 10 tuples means in a particular relation, the n value is 10. See, nc is the number of training examples from class yj that take on the value. See, nc is the number of training examples from class yj. So that if you are calculating whatever the for example, see, n is the total number of instances from class 1. For example, I have 10 tuples means n value is 10. See, nc is the number of training examples for class 5. For example, that in a particular class variable, the yj value, the nc values are category attributes, so that they have a 3 or 4 values. Okay, for example, because in the default borrower case, in default borrower case, we have 2 values. Okay, the 2 values are yes or no. So that nc is the number of training examples from class yj that take on the value. So that nc value is 2, n value is 10 values. Okay, m is a parameter known as the equivalent sample size, and p is a user specified parameter. So that these two are the independent each other. P, you have to specify P as a particular parameter. He has to give some particular parameter. User has to give some particular parameter. See, M is a parameter known as a equivalent sample size, based upon the whatever the data you given in particular what we call as a relation. Based on the user is calculating some user specified parameter, you have to assume the user specified parameter. Based on this, you have to calculate equivalent sample size. Equivalent sample size means simply we can call it as mean value. Okay, if you are calculating mean value means, so that based upon the, for example, I have find 5 training data set. Okay, so that 5 training data set, you have a mean value. You have to calculate m is a parameter as sample size means a mean value based upon the given 5 values. Okay, so 5 and m is the mean value, n is the total number of values, and nc is the what we call as particular categorical value, particular type attribute type values in a class label. Okay, in textbook there is no particular what we call as uh, particular example. There is no particular example, so that they, it is research oriented, so that he stopped particular concept from here only. Okay, right. And last one is next. Last topic is Bayes error rate. What do you mean by Bayes error rate? See, if you are taking what we call as an attribute which is correlated to each other, then there is a problem called as we will get a 0. Okay, so that you have to find out that error with one of the important point called as Bayes error rate. See, if two or more values are looking as identical, so if two or three values which are identical to each other, then we have to perform with the help of Bayes error rate. Okay. See, we will take an example. The Bayesian classification method, which allows us to determine the ideal decision boundary for the classification task. See, why we are using the Bayes error rate means, so this is a Bayesian classification model which allows to determine the ideal decision boundaries. Ideal decision boundary means say same. Ideal means same. Decision boundaries means you have to assume some boundaries so that for a same attribute type of data, you are assuming some boundaries. For the classification, we use Bayes error rate. See how you can easily identify means with an example. See, this is a consider task of identifying alligators and crocodiles. See, these alligators and crocodiles, these two are looking as same based on their respective lengths. Length is a boundary. Okay, we assume length is a boundary. Based on the length, these two are looking each other. So it allows us to determine the ideal. Ideal means looking decision boundary. Ideal decision boundary means looking like same with same length of the features. But the average length of an adult crocodile is about 15 feet, while the average length of an adult alligator is about 12 feet. Okay, so but looking as same, but the difference is the length is a particular boundary. Based upon boundary, if two or more values are looking same, with the help of boundary, I am identifying Bayes error rate. If there is an error, with the Bayes error rate, we are easily identifying. Assuming that their length x follows a Gaussian distribution with a standard deviation equal to 2 feet. See, for example, a maximum feet of particular what we call as these two features or the species are 2 feet, so that it should not be grown up to 2 feet. It should be grown up to till 2 feet. Okay, so equal to 2 feet. We can express their class condition probabilities as follows. See how you can follow. This is an example. So if it is a numerical value means you calculate with the particular equation like this. Similarly, if it is an alligator, we are calculating with this. Okay. So where is the difference here is? We are calculating, this is sigma value, we are assuming that x is minimum 2 feet, so that the value is 2. Okay. I think now you are following some graphs. Okay. See, you are saying that, see, if it is a 0 to 12 length, here is the common point. So up to here, you can assume that, see, minimum looking like as same feet. See, this is alligator looking as same feet, and this is a crocodile looking as same. By looking, these two are same. While calculating based upon the length, you have to see assume that this is a marginal point for particular what we call as, this is called as alligator. Okay, from here to here, you can say that it is an alligator. When it reaches this particular value, you can say as this is a crocodile. Okay, because the average is here is 12. Okay, here is 12 and it is grow 15. Then it is a what we call as crocodile. Okay, I hope you understand this concept. Okay, so the ideal decision boundary is located at some length such that x bar, we are assuming crocodile and we are assuming alligator. Using these two equations, we get a value. We are calculating the value, which is value called as yield value, that is 13.5 value. Based upon this 13.5 value, here you are getting a 13.5 value. Okay, here we are getting a 13.5 value. you can from this feature this 13.5 value to 15 value. Okay, so that you can within this boundary you can say that the alligator size will be from here, the length should be 13.5 boundary. From 13.5 to 0, if there it is the length, then you can say that it is an alligator. If there is an above 13.5, you can say that is a crocodile. Okay, maximum is how many feet? 20 feet is the maximum distance. It not be more than 20 feet. Okay, less than 13.5 means it is an alligator. More than 13.5 means it is in a crocodile. Okay, so I hope you understand the total error rate is known as the Bayes error rate. See, by this equation you are calculating 13.5. The decision for this example is located halfway between the two means. Okay, I hope you understand this concept. In next class we discuss last topic of this unit is Bayesian belief networks, and this is a advanced topic, and what we this Navy based classifier is also an advanced topic, but Bayesian belief networks is a purely advanced topic, and this Bayesian belief networks will comes in machine learning, but in normal we can discuss in next class. Okay, so that we will complete fourth unit by tomorrow. Thank you all.